For your Unit 6 video, we're going to be looking at factoring polynomials of any type. So shown on this side is your factoring flowchart. So remember that you always start up here with the word factor. So when I ask you to factor, the first thing that you always do is look for a GCF. So after you've pulled the GCF out, you have to look and see how many terms you have. If you have 3 terms, you're going to factor it using the box or the shortcut. If you have 4 terms, you're going to factor by something called grouping. And if you have 2 terms, you're actually going to have 3 different options. So for the following set of notes, I'm going to go over each and every one of these methods of factoring. So there's actually 7 different methods of factoring that we're going to look at, and they all should be a review. Okay, let's look at GCF first. So if you'll remember when we worked with GCF, what you're looking for is the largest number that you can divide both of the terms by. In this case, it's a 9. So you write the 9 out to the left and open those parentheses, and then you actually just divide by a 9, giving you 9 times x minus 2. For this second example, I wanted to point out that there's a negative for the first term. You do not ever want to have a negative for your first term. So the GCF among all 3 of these happens to be an A. If your first term is a negative, you actually want to pull that negative out with the GCF. And what that'll do is you'll divide a negative A from all of them, and it'll pull this negative from the first term. So that would leave you a positive a squared and then a negative 3a and then a positive 5. So it changes all the signs of everything that's on the inside, but it also pulls the negative out of the front, which is what we wanted. And this would be your final answer if you're just pulling a GCF. Okay, let's take a minute and look at factoring by grouping. Factoring by grouping is something that you do when you have 4 terms. So when you have 4 terms, the first thing you look for is a GCF, like we always talked about. And then once you realize there is nothing all 4 of these can be divided by, you actually split the first 2 in its own set of parentheses and then the second 2 in its own set of parentheses. Be careful and notice that that negative ax squared, that is 1 term, so I had to put that together in the parentheses. And then what you do is you look for a separate set of GCFs. So for example, between 3x minus 3y, there's a GCF of a 3. So I'd pull that 3 out, divide by 3 and divide by 3, and I end up getting x minus y. And then you go into your second set right here, and I notice that I have a negative for my first term, meaning my GCF is going to have to be negative, and then I can pull an a from both of them. So my GCF from that second set of parentheses was a negative a, which is why I put a minus a down here. And then you divide by a negative a and divide by a negative a. That gives you a positive x minus positive divided by negative gives us a minus here, minus y. Now the goal is to get these parentheses to look exactly alike. If you get these parentheses to look exactly alike, you did what you were supposed to do. Then you're ready to come down to your answer. So the first part of your answer is these 2 numbers on the outside, so 3 minus a. And your second parentheses is these 2 numbers. You just choose one of them, x minus y. So your answer would be 3 minus a times x minus y. Okay, let's look at factoring trinomials. When you have trinomials, what you really want to focus on is whether there's a number in front of x squared or not. So in this case, there is a number in front of the x squared. We're going to have to use the box. In this case, there's nothing or a 1 in front of that y squared, so we can use the shortcut. And I want to give you a chance to show, I want to give you a chance to see both of them. So let's start up here. This has a 12 in front of it, so I know that I'm going to have to use the box. And we've been working with the box in class, so this should be semi-familiar to you. The 12x squared and the negative 2 go in the box. And then I need 2 things that are going to multiply to a negative 24 and add to a 5. And the negative 24 came from these 2 numbers right here. So 12 times negative 2 is negative 24. And the negative 5 came from right here. That's what I'm trying to replace. So what 2 things are going to equal a negative 5 and a positive 24? Well, it's going to be negative 8 times 3. So instead of a 5x, I'm going to have a negative 8x and a positive 3x. And then I'm just going to pull my GCFs. So my GCF here is a 3x, my GCF here is a negative 2, GCF here is a 4x, GCF here is nothing or a 1, and it's positive, making my answer 3x minus 2 and 4x plus 1. Now let's look down here at your shortcut problem. Remember, you can use the shortcut as long as there's a 1 in front of that first term. And to use the shortcut, you basically go straight to the multiplies 2, adds 2 chart. You skip the box completely. So what you say is you want it to multiply to the last guy, in this case negative 35, and you want it to add to the middle guy, in this case a positive 2. So what's going to multiply to a negative 35 and a 2 is going to be a 7 and a negative 5. Once you get a positive 7 and a negative 5, you actually go straight to your answer. So the y squared breaks into y and y. The positive 7 becomes one of your answers, and that negative 5 becomes the other one of your answers, and you're finished. Okay, let's look at factoring your binomials. So there's actually 3 different ways that you can factor binomials: difference of squares, difference of cubes, and sum of cubes. How can you tell which is which? Well, the first thing you need to look at is what you're given here. So if it's difference of squares, you better have a square. If it's difference or sum of cubes, you better have a cubed. The other thing you need to look for is if it says difference, you better have a minus sign. So difference of squares, you better have a square and a minus sign. Difference of cubes, you better have a minus sign and a cubed. Sum of cubes, you better have a sum or a plus and a cubed. And then thirdly, you have to look at your number. So if it's difference of squares, we have difference minus squared, squared. It better be a perfect square. Square root of 16 is 4. If this number is not a perfect square, difference of squared is not going to work. Same thing for your cubes. Difference of cubes, difference minus sign, cube, cube, better be a perfect cube. Well, the cube root of 8 is 2. Sum of cubes, sum, we've got the sum, cube, we've got the cube root of 27 is 3. So it has to be a perfect cube. So let's start up here with difference of squares. For difference of squares, you actually go straight to your answer. For difference of squares, you actually just square root both of the terms. One of your parentheses becomes a plus, one of your parentheses becomes a minus. So the square root of p squared happens to just be a p, so that p breaks into p and p. Square root of 16 happens to be 4, so we get a positive 4 and a negative 4, and you're done. So difference of squares, square root. For difference of sum and cubes, you actually have a formula you need to follow. So for difference of cubes, the formula looks like this. So it looks like for my formula I need an x and a y, and once I figure out what my x and y are, I can just plug it into that formula. Well, the way that you determine your x and your y is you actually cube root. So remember, difference of squares, square root, difference of cube, cube root. So the cube root of m cubed happens to be m. In other words, my x term is m. So anywhere up here in my formula that I see an x, I'm going to replace it with an m. Cube root of 8 happens to be 2. Anytime up here in my formula that I see a y, I'm going to replace that with a 2. So that's how you find your x and your y. So if I'm going into this formula, instead of x minus y, it's going to be m minus 2. Instead of x squared, it's going to be m squared. Instead of x times y, well, 2 times m is 2m. And instead of y squared, it's 2 squared, or 4. And that actually is my final answer. For sum of cubes, once again, it's a very similar looking formula. The only thing that's different is your plus and minus signs. So it's minus plus minus. Up here it's minus plus plus. Oh, excuse me, I messed that up. It's plus minus plus. There we go. So for the formula up here it's minus plus plus. For the formula down here it's plus minus plus. But it's a similar fashion. You need to find your x and your y. So my x and my y, since it's sum of cubes, we're going to cube root. Cube root of r cubed is r, so my x is r. Cube root of 27 is 3, so my y is 3. So instead of x plus y, it's going to be r plus 3. Instead of x squared, r squared. X times y, we're going to multiply them. 3 times r is 3r. And y squared in this case would be 3 squared, or 9, giving me my answer right there. Last but not least, I want to look at how to solve. So when we solve something that's linear, we just get the x by itself, and everything's fine and dandy. When we solve something that's quadratic, or in other words, it's got a squared term in it, we have to do things a completely different way. One of the multiple ways to solve quadratics is to set it equal to 0 and factor, which is why it's in this chapter, because it involves factoring. So for example, if I was looking at this problem right here, the first thing I would want to do would be to set it equal to 0. So I would actually want to add this x over here and subtract this y over the equal sign. You got to get it set equal to 0 first. So the 2x squared would come first, and then I would add that x over, and I would minus that 3 over and get it set equal to 0. Once you get it set equal to 0, you factor it. This x squared, it's a trinomial. This x squared has a 2 in front of it, so I'm going to have to use the box. So I'm going to need two numbers that multiply to a -6 and add to a 1. Remember, the -6 came from right here, and the 1 came from right here, 1x. So it multiplies to a -6, adds to a 1. Let's see, it's probably going to be 3 minus 2. So 3x and a -2x. And then you pull your GCFs out. And it looks like my factored answer is 2x plus 3 and x minus 1. Now that's a factored answer, but I still haven't solved for x. Once you get it here, you actually split this into two separate problems. So you set the 2x plus 3 equal to 0, and then you also set that x minus 1 equal to 0, and then you solve for x like we're in Algebra 1. So minus the 3 over, divide by 2, and x equals -3/2. That actually is one of your answers. X is possibly -3/2. And then over here, add the 1 over, so x is possibly a +1. Now remember, if you have an x squared, you're going to get two answers. So that's why we got two answers, is because it was an x squared.